You spin it just a second.
My name is Roy. You're not fascinated with seeing some guy with a face that's not made for television. This is all about this motor. What you're looking at here is a model of what I believe is the most advanced engine design for pistons that has come along yet. What I'm going to try to do here over the next few minutes is explain what this thing is about a little bit. And I call this crank, I call this a wave crank. And up here, this whole assembly that's going in this giant hole that I have cut into piston number 1 right now, this whole assembly, I'm calling it a FIP, which is a piston and head in piston. What you're looking at are pistons, numbers 1, number 2, and number 3. Piston rings, I've just drawn on here with markers, with a red and a blue marker. You can see those. Piston number 1 functions like any other piston, meaning that it comes up and bangs into its head. It has its own head and cylinder sleeve that go on the outside of this entire arrangement. And the head for piston number 1 is up here. Its high gas phase occurs on this side of the head of the piston. This is piston number 2. The rings on piston number 2. Piston number 2 is actually two things. It's a stationary head as well as a functional piston that takes advantage of the motion of piston number 1, alright, and its location in here where it can go ahead and form an ignition chamber on the underside of the cap of piston number 1, alright, giving you two explosions that you can have occur, two pieces of drive on the same piston. There's a third compression chamber built into this, and the reason that I say compression chamber is because in my mind this particular design is going to be its most effective when you use piston number 3, again built on the other end of this same stationary head and interior head. That's what it is. It's a head built inside piston number 1, and again, the rings are located on what is effectively the head. I'm taking advantage of the piston's motion on this end, putting another piston cap in underneath here where you can't see it. And I'm using this as a compression chamber, alright, to compress air for cylinder number 2, which is an ignition cylinder. That will let you balance out the amount of thrust that you get from each piston, because piston number 1 is inherently going to be a larger piston than piston number 2. So if this was going in 2-cycle phase, you could literally have hits going in both directions constantly. You'd always be pushing in one direction or the other. Instead of spinning in this direction, like a normal crank would, this crank spins in this direction, like this. And let me show you how. This is a freewheeling. Rather than the bearing connecting to a single point on the crank, the bearing slides on the crank, and the motor runs a little bit like this, and the way she goes. This one's running on a 2-to-1 reduction because it has 2 connection points for this giant, ridiculous yoke assembly here to connect it to the crank. And production models of this engine would not only have an interior drive in there, they'd also probably be reducing it more like 4-to-1 or 5-to-1 ratios, which means that this wave right here, instead of going up and down twice, alright, in its 360 degrees of turn, would go up and down 4 or 5 times. 8-to-1 reduction if you want it, right off the piston itself. This is more efficient than other engines in a lot of different ways. Okay, for starters, one of the biggest problems that you have with conventional motors is that in order to develop high torque, you need a long piston throw. In order to develop high RPM, you need to have a very short piston throw. And so all engines basically are the result of a compromise somewhere between those two. And the compromises of a very limited range. The difference between a 2.5-inch stroke and a 6-inch stroke is huge. I believe that this engine in a 200 horsepower unit would be able to do in excess of 30,000 RPM just because you don't have all that excess radial motion. You don't have that long crank that's going, front to back in the engine, and all the potential for vibration. I mean, this is meant to run as a 4-cylinder engine, which would look at some rough approximation like this. And as a 4-cylinder engine, I would be using the combustive process on 2 of the cylinders. I would be using cylinder number 2 for fire, cylinder number 1 for fire, which means that I'd be firing on both halves of this piston cap down here. And I'd be using cylinder number 3 as a supercharger to boost cylinder number 2 so that it can equalize out the power of piston number 1, because piston number 1 is larger, since piston number 2 is, or actually the head is functioning as a piston here. The stationary head has rings built on it. That's what that blue and red line are all about. The rings go on the head, all right, and then they run along the interior of the piston in 2 locations down here. You use number 3 to supercharge number 2. That gives you a balanced shot between numbers 1 and 2. And you come down here and you do the exact same thing. Nothing different in any way, shape, or form. When you have 4 cylinders firing all in a single line, which is what this offers, which no other engine can do, what you end up with is you end up with push on every stroke in every single direction. One nice thing about building a motor in which these loops are custom made is that also means that you can customize your combustion loop. What you can do with a wave motor is that you can custom shape your combustion loop. You can have that plug fire, all right, and then you can cheat the shape of this drive, all right, as it's coming along, and you can turn the high gas phase into 22, 25, maybe even 30 degrees of high gas phase loop. With custom shaped waves, what you'll be able to do is you'll be able to do as much as 250, 270 degrees of compressive stroke, because you can cheat with the shape of the wave. This crank is going to end up becoming the main pilot gear in the transmission. That would almost be a trans engine, you could call it, because this gear right here, which is what this would be, once you put all the hardware to the inside and you turn this into this outside face is smooth and it just has a simple gear on it, and what's going to happen is that this will become the pilot gear for the transmission. So you literally have this transmission built, all right, with this piece of hardware with 2 legs sticking out of each side of the center line of the transmission, which is where the pilot gear would be.
If you take an existing car and replace its current regular internal combustion engine with this engine, how much more mileage will I get? If my current car is giving 30 miles per gallon.
A 30 mile per gallon car should be getting somewhere between 36 and 40 miles per gallon. So you end up with a 6-cylinder engine, all right, with exactly 2 moving parts. We're going